Welcome to 4.2 Operations with Matrices. We're going to add and subtract matrices and multiply by a matrix scalar. So let's start with the key concept of addition of matrices. The idea is that if the two matrices have the same dimensions, we can add the corresponding elements of those matrices. So we'll start with an example. We're going to add matrix A plus matrix B. By definition of matrix addition, we can substitute those matrices in and add them. Then we're going to add the corresponding elements, and we're going to simplify to get 1, 1, 7, negative 6. Part B, since the dimensions of A are 2 by 3 and the dimensions of B are 2 by 2, we cannot add these matrices. We can also subtract matrices in a similar manner. As long as the dimensions are the same, we find the difference of the corresponding elements. So we can subtract these two matrices. We're going to do A minus B, so we can use the definition matrix subtraction, and we're going to substitute those matrices in and subtract them. We're going to subtract the corresponding elements, and then we simplify to get 6, negative 4, negative 12, 9. We can use matrices to model real-world data. So here we got the table that shows the number of endangered and threatened species in the U.S. and in the world. The question is, how many more endangered and threatened species are there in the world list than on the U.S. list? So we're going to make matrices out of these, and we're going to leave them in the columns and the rows that they already are. Right? 61, 8, 74, 15, 14, 22, 9, 8, 69, 42. But we're going to use we're going to find the difference of the matrix that represents species in the world and the matrix that represents species in the U.S. We're going to take the world, which is the second matrix. We're going to subtract the first matrix. So we got 309, 24, so on and so forth, minus the U.S., which was 61, 8, 74, so on and so forth. We're going to subtract corresponding elements, and we get our answer, which is 248 and endangered mammals, 16 threatened mammals, 178 6 endangered and threatened birds, 6514 endangered threatened reptiles, 8 and 1 endangered threatened amphibians, 11 and 0 endangered threatened fish. Our next key concept is a scalar multiplication. You multiply any matrix by a constant called a scalar. The operation is called scalar multiplication. The idea is we can multiply by a constant, in this case k, and we would multiply each element by that constant k. So we're going to multiply a matrix by a scalar. The scalar is 3, so it's 3 times matrix A. We're going to then multiply each element by 3, simplify, and we get 6, 24, negative 9, 15, negative 27, 6. So many properties of real numbers also hold true for matrices. So the idea here is we have commutative property of addition. We can add matrices in any direction, right? We can move around where the matrix is. The associative property of addition, we can group the different matrices differently. And the distributive property, we can multiply each matrix by the constant. So we're going to use a combination of matrix operations. Here, we're going to perform the scalar multiplication first, then we're going to subtract the matrices. So we're doing 5 times matrix A minus 2 times matrix B. So we're going to substitute those in. We're going to multiply each element in the first matrix by 5 and multiply each element in the second matrix by 2. So we simplify here, we get 35, 15, negative 20, negative 5. We're going to subtract the matrix 18, 12, 6, 20. We're going to subtract the corresponding elements, and then simplify to get 17, 3, negative 26, negative 25. That's it for matrix addition, subtraction, and scalar multiplication. Good luck on the practice.